Hey, want to do a little intro video to the CNC router that I built. I call it the RiNo route because I am in the RiNo Art District in Denver, Colorado, and it's a popular name. So this is the router. We have a very simple old PC. I believe it's running Windows 7, but the key point is that it has the parallel port out the back to a breakout, and it's running Mach 3. It is a 4x8 platform, a little bit bigger than that, and it has a 6 inches of vertical Z-axis, although it would actually handle 8, which the next redesign will include the upgrade for all 8 inches. So for a little bit of a tour here. 600-watt spindle purchased off of eBay. It is brushed. It has been working pretty well for me so far. I haven't had any real major issues. It keeps up with everything that the machine can do. 3D printed, designed by myself, vacuum extraction with compressed air nozzle from the air compressor, which this is one of the most important things about CNCing, is clearing the path for your bit. This makes an amazing amount of difference. Z-axis is a C-beam 250 millimeter bought from Open Builds. They're all NEMA 23 motors. This one's a little bit smaller because it doesn't need to do as much work as the rest of them. Works pretty good. It did come initially with this plate and these plastic bearings, which I found to be insufficient. The bearings aren't plastic, but the wheels are a very hard plastic. But then I did switch it to the V wheel. Let's see if we can get a good angle on that there. So, and that helped out quite a bit, although it did create a clearance problem, which I have not yet fixed yet, but I do need a little bit of machining. But otherwise, linear rails purchased off of eBay for both the X and Y. And you will see here, this is not tight enough, but this is a 5M belt, HTD. HTD referring to the profile of the teeth, and the 5 being 5 millimeter spacing. And that is both the same for top and bottom belt drive. NEMA, the X and Y are NEMA 23s. I think they were like 384 newtons, but these have gearboxes which gear them down. I believe these were 4-to-1, 4.25 to 1, which gets is just a way of getting it down to 1/10 of a millimeter of accuracy. Basically, there's a little bit of play in the gearbox, but I decided that based on everything that I was building, that should be no big deal. All of my, what do you call this stuff? I forget. Cable tray. There's another name for that. Anyway, all this was purchased off of eBay. I wasn't going to print this all myself, but I found out that as time and cost just didn't come anywhere near to as competitive as eBay. So these are all designed and printed. The cable holders and runners, those are printed and designed by me. And we have a very large cable tray. That's eBay as well. Let's see if we can get some good light on that. There we go. These pop open, which you need a screwdriver apparently. I haven't done this in a while. Anyway, so I designed, you can see here, this is a 3D printed tray cable holder, which these are very weak. I broke many of them, so they've all been replaced with a very simple wood version, which is quite a bit more sturdy. All the wiring is color-coded, and I have a diagram that matches everything up. For the most part, it's a little bit of that has been lost track of, but so far so good. It has a wood base on wheels. The actual table is metal, and I've put it on adjustment screws. There are 3 on each side so that I can level and adjust for anything in the floor, essentially. And belts, I've made custom tighteners. These are all 3D printed and designed by me. They work pretty good, but I found that just yanking the thing as tight as I could possibly get it with my hand. This is appropriately tight. The ones on the X are not, but it hasn't been detrimental. And then last but not least, I've got all my ins and outs here, so I could test them easily if I needed to, running into my box, which in this is custom built electronics box. Everything is, make sure we're like right side up, but mostly labeled. It's a little dusty there. I do have a fan on the front. And apparently the computer's off because that just lit the spindle up. But anyway, there is 2 power buses. There's a 36 and a 12. 36 runs the spindle, I believe, and there's also a 5-volt bus for the driver power up, essentially. So I don't know if you can see my hands, but let's get a good angle on that. So 12-volt, 36-volt power supplies. This is the spindle driver. These are my access drivers. That is the 2 large capacitors for smoothing, which, on a side note, those are the last 2 things I ever bought at the electronics store in Boulder, which recently went out of business, which was a major loss to electronics aficionados everywhere. I think that's it. I mean, you can kind of see in the back there's the parallel breakout board. That's all. I just put that in a server rack case. Oh, and this is manual speed control for, oh, that's getting loose. Manual speed control for the spindle. Because I had never figured out the PWM, and I found out that running it by audio, I could get pretty much good enough. So I have a air compressor sitting here, bits and tools. That's, you know, just the basics. These don't fit, but someone gave them to me, so I will make them work later. And then the computer. And running Mach 3. All right, and there you have it.